Hello friends, so today we will create a car segmentation model using a YOLO. So let's get started. Before that, I want to download the Roboflow library which we require to download the data set from the Roboflow. Okay, so this is you can see the code of the code to download the data set from the Roboflow. Let's get started. Okay, it will take time to download the data set. So this is you can say this is a data set name car1, but I want to rename it according to the name which I want to cap. I want to cap this car segmentation data set. For that purpose, I want to use this if statement. If os.path.exit means old name is exit and a new name is not exit, then we will rename it to the new name. Okay, let me run it now and let me refresh it. As you can see that we get the car segmentation data set name. Okay, we have this thing. How many number of classes which we have? We only have one classes, that is car. Okay, so let me get started for training the model YOLO model to YOLO model for car segmentation. For that purpose, we require the Ultralytics, which we require to you can say to load the pre-trained model YOLO model. The model which we are using is YOLO11L segmentation.pd. Okay, okay, it's not required here. We do not need this line comment. This is extra. Okay, now first of all, to train the model, first here we load the pre-trained model. Now we have to train the model on a custom data set. For that purpose, we have to use model.train means the data, where you can say we have a data YML file which is required. The epochs, right now I just want to train it for the 10 epoch, or I want to train it just for the 5 epoch, because I already have a model which is trained on 50 epoch. I will show the result of that. Image size will be 640. Batch means when the images are divided into batches, then each batch should have 8 images. Name means what is the use of this name. When suppose when I will run this cell, it have here the run folder will detect will generate automatically. Inside the run folder, segment folder will be there, and inside the segment folder, one folder will be there which store the weights. So the folder name will be this, which we have decided according to us. This be the folder name inside the segment folder. Save true, yes, we want to save the you can say model weight file. Save period -1, we do not want to save every epoch weight file. Save true means we have to save the weight file, but we do not want to save every epoch weight file. Patience 20 means right now patient 20 will not work here because it's a early stopping, but we only training for the 5 epoch. Patient 20 basically it used for after every 20 epoch. It will see that the training is means the loss is going down or accuracy is increasing. If there is no improvement, it will stop the training and we will save the best model. Validation true, yes, we want to validate the model also. And here you can see we have we have a less number of images. So according to that, to increase the number of images, we use the data augmentation. So this is a data augmentation which we had applied. So for that purpose, we used degree, translate, scale, share, perspective, fill up, flip any, flip UD, flip LR, HSB, HSBS. These are the data augmentation which I will apply. So let me run it so that we can start a training for the 5 epoch. After that, this is a function to give me the segmented image. When the model will predict the mask, I want to use I will just pass the image and mask here with the class color, and I will get the segmented image. I will not explain this function because I will not explain you this because I already explained this whole function detail way in my video. Go to my channel, you will see this video. You will play this video. You will get a complete explanation of this function. Okay, but in short way, it give me the blended image, or you can see the segmented image after just passing the image and the mask both. Okay. Okay, now let me run this cell. Now we have to test the model. For testing the model, first of all, we have to load the model which we train a custom data set. For that purpose, we have to give the path. I think so. See, inside the run folder, segment folder, and inside the segment folder, one folder will be there whose name is decided by us. And inside that, weight folder will be there. Okay. So inside the weight folder, 2 weight file will be there. When you can say when epoch 1 will get complete, you will get a 2 weight file, best and last. We will use best.pt. So we have to give the during testing time, we have to load this best.pp weight file. So this is, you can say this is the path of it. You easily load the pre-trained model. Okay, which is trained on a custom data set. After that, this is a, you can see the test directory. This you can say the test directory. Then we have only two classes, zero for the background and one for the, you can say, uh, one for the car segmentation, which we are using it. This is the pink color we are using for the segmentation. After that, we have to make the list of all the images present inside it. So this is a list of all the image and name present inside the test directory. For the plotation of the 16 images, we use for the plotation of 16 images, we use plot.subplots, 4 rows, 4 column. Figure size will be 16 by 16. Figure basically represent the entire subplot. X just for the iteration over the subplots. X dot will convert the 2D into 1D to the X, which is easy for the you can say flow over the segment subplots. For the plotation of the 16 images, we loop for loop for the 16 time. Then we randomly select the image name using the image files which we have created, a list which we have created. Randomly select the image file name. We have to make the complete image path. For that purpose, we use this os.path.join test image directory, and the image name will get a complete image path. After that, we will read that image. After that, we will read the image, and you already know that we able to read the image in BGR format, so we have to convert it into RGB. So here the CBT or CBT color is required to read the image to convert the image from BGR to RGB. After that, we will just pass the image path. Either you can pass the image path or the image, it's up to you, but here I am just passing the image path. After passing the image path, it will predict the mask. Okay, and we are just passing the single image, so 0 will give me the complete prediction of the single image as a result. After that, if the result dot mask, if the mask is predicted by the model, then only we will have to move to inside the if loop. And here we're using a for loop. Why we are using the for loop? Because if suppose in a single image multiple object is present, so multiple mask is present for single object. Okay, so at that purpose we have to loop over it one by one. So that's why we use result on mask on data. We'll loop over it. After that, we will you can say here we move the you can say move the mask, or you can say this segmentation mask from GPU to CPU, and also convert that into numpy. So this is the line which we're using it. After getting the it, we have to resize the mask according to the image which we have, which we have load. According to that only we have to resize the mask. Why? Because the model which we have trained on YOLO, it's have you can see it here. We have to resize the image to 640. So during testing also, it automatically change the dimension of the 640 and also give the mask. Let me show you. Let me print the mask dot shape. Okay, for better accuracy, better understanding, and here also print the resize shape. Okay, now just break it, just break everything. Let me see that 5 yes, training is completed. Let me wait. No, it's telling it's going on. Last epoch is going. Then I will explain you that how it's working. Okay, so mask dot it's resized according to the shape which we have. Okay, then we will draw the segmentation. Just go call a draw segmentation function I have not explained in this explanation, because I already explained this that function clearly in my video. Go there. After that, we will use just after getting this, we have to convert that image into RGB. Okay, then we will show the image here. We will get this type of result, but let me show the result of the model which is trained on 5 epoch. Okay, so the training is completed. Training completed. Wait for the seconds. Yes, training is now completed. Now let me show you the result of this. That print dot mask shape, which the prediction made by the model. See, wait for it. $16 time also. Okay. This is the problem here. We only want to do for the one time only. Okay, break. Here required the break, and also one more thing, that the image which we have read, yes, this one. Image dot shape. I think so. They all are in 640 images, so there is no need. I think so. Wait for it. Let me check. Yes. The dimension is 256 256, and you can see that in mask shape will be 640 640. After resizing it, its shape changes to 256 to 256. And why the mass predicted mass shape is 640 640? Because during training we have fixed the size of the image is 640, so that's why it predict the mass also in a shape of 640 640. I hope you understand well why this resize is required. Okay, no problem is there. Now let me comment the extra line. Now let me run it for, and now let me remove the break. Now let me show the result of the model which is trained on 5 epoch. Okay. See, it's not working very well, but somewhere it's working very well. Now how we can improve the accuracy? Okay, just it's very simple. It is just you have to increase the uh, epoch value. Okay, let me go up. Now I think so. Let me train the model for the tiny epoch. Okay, but let me train it for the tiny epoch then, and let me come back when it's trained for the tiny epoch. Then I will show the result of that. Okay, how you can increase the accuracy and increase everything. But as soon as you run the cell, the folder name which we have decided will get changed. Let me show you. You can see it now. There will be two folder. As you can see, it's having a two folder. The folder name which we have decided is this one, but this is not decided by us. So according to this, we have to make the changes in every code. Okay, so move down and changed here. We have to change this here because it's now dash 2 means the latest model or a weight file which is trained on tiny epoch will store in this folder. Okay, so let me run it again. Now let me come back when when this model is trained for tiny epoch. Then I will show the result of the model which is trained on tiny epoch and see the result of that. Okay. So our training is completed for the tiny epoch. Now let me show the result of the model which is trained on tiny epoch. Okay. So let's get started. Let me show the result of the model. Oh, it's the model result which is trained on tiny epoch, and it's pretty much doing very well. If you want to increase the you can say accuracy more, now you can increase the number of epoch, more training will be there, more accuracy will be performed. Okay, so I hope I understand. If you gain something from my video, please like, share and subscribe my channel. Thanks to all.